What I'm going to do today is I'm going to give a basic demo of Puppet Enterprise, showing you kind of the features, what we can do with configuration management, and as well as what Puppet Enterprise adds on in addition to general open source Puppet. So what we're looking at here right now is the basic screen. You log into Puppet Enterprise, and this is what you see. Some sort of quick hit run stats, all the nodes you have in your system, and how there are. And then we can actually drill into these nodes here. And I can get additional information about them, including what groups they're in, what classes are assigned. If you guys are on the open source, you know that while this seems like a simple thing, finding out what classes really are applied to a box based on a bunch of regex keys is kind of tedious. And then let's make this a little wider. Run statistics, and then reports, and finally the inventory, which is the factor data. This is something that Ryan had touched on earlier this morning. If you're not familiar with factor, factor is all the information we collect about a node, and this is what we use for things like classification, filters, for something like mcollective. This permeates the entire system, and you'll see in many different areas where the factor data becomes relevant. And this includes a lot of built-in information, the hardware model, the operating system, all that, as well as custom facts. So here I've created one for data center, but anything that you can query, you can run a command against, I can create a custom fact for. So if it's running in AWS, I can query AWS metadata, figure out where is this thing. I wrote a custom fact for a client to query all the SQL instances to figure out where the log files in the databases were. So you can do this just to collect the information if that's what you want, but also use that later in classification or orchestration. And then we can actually drill down here into the reports. And you can see exactly what would be shown if you're on the command line kicking a Puppet agent runoff here. And one of the nice things here is you can see the events, everything that's been changed, everything that's unchanged, everything that's been handled by Puppet. And I can see down here to the line of Puppet code that is causing this to be managed. So if I have a failure, I can very quickly see, hey, this is where why I'm managing this. I know what file to go look at, what manifest and what class, what line is causing that. And then here, we also have this file bucket, which is turned on by default in Puppet Enterprise. So I can come in here and I can see previous versions of files. If I'm modifying a configuration file, I would prefer that you guys have everything in Git so it's all in version control and just go back to the previous version. But this also gives that extra little safety catch of like, hey, I grabbed those files, threw it up in the server. If you need to go grab the old configuration or it's something you hadn't managed before and something got blown up, you can grab that right here. So next on here, on the enterprise, we have our classification, our classifier. This came out of, there are several different ways you can do classification in Puppet. One site.pp, one with Hira, and then historically we called it an external node classifier. Fancy name for go write something yourself, and we'll talk to it. With Puppet Enterprise, we now baked in a very powerful external node classifier that it gives you the ability to come in here and create groups, and then do queries based on these facts, again, that I just mentioned. So anything here I can do is, I can do greater than, is not, any of that using both the built-in facts and the custom facts. So this is a kind of area where I can say if your provisioning tool can drop in a fact that says this box should be a web server, I can look and find that fact and use that for classification or any other mechanism that makes it easy and extensible for you to do that sort of, to put things on there. And especially now where things like AWS wants to manage the host name. So the legacy way of like, I'm going to throw the role of this box into the host name is no longer really the best way to scale. And this allows you to use those other details to figure out what something should be. And so I'm going to go here and actually modify. One of the nice things, so I'm going to put classes in here, and then I can modify the variables from that class. So I can say servers. Right now it's pulling it from the default, but I can come in here and say I want something like 0.NorthAmerica.pool.ntp.org. Add that parameter. and commit. And this activity gets tracked here that, hey, look, I made this change. So if you do need to come back and see when did this get changed, when this classification get updated, I can see the user that logged in and what they did. And then if I come, can you read this on here? Yes, great. So I can do a Puppet run, and then how many of you guys are familiar with no-op mode? Yeah, so no-op's one of the things that really sets us apart from legacy scripting, things like that, where I can come in here and do a dry run to see what would happen. So you can see the change it would make is it would remove these 4 servers and add this one. And let's just actually run it here. So by default, Puppet would have run every half an hour. It would have picked this up eventually. What I'm doing is I'm just kicking it to make it actually happen now, so that we don't sit here and wait half an hour while I talk to see stuff. And now you can actually, so this is another thing that the Puppet Enterprise brings that really makes your life as an administrator a lot easier versus the open source or things like Foreman put together. With Event Inspector, I can come in here instead of looking, so if you have a resource that fails, you're going to get a report back, and you can look at that report and see what happened. You can do that on the open source as well. If you have 1,000 servers where a resource failed, you now have 1,000 reports to look through. And looking at the node level, the report level, is not always the most convenient. If you want to see, was it really just one resource or one class that failed everywhere? Or is it 1,000 that failed on this and then 10 and something else? Well, I'm not going to go look through everything to find that. Here with the Event Inspector, I can very quickly see, oh, by resources that changed. These are the resources that changed. These are the nodes that they changed on. And here's the actual message that happened. And I see the same thing if my failures are in here. I can see the failures right here. Very quickly troubleshoot, get to your problems, and figure out what you need to do to get the situation fixed. And then this will take you back to the run report for additional detail if you need that. Yep.
Classification. How do you see the hierarchy? Let's say you have, of course, web servers, but you have sources performing Apache stuff as opposed to API connectivity.
Yeah. So right. You want to see the interconnectivity between the different systems, or? Right. Yeah. So it comes down to sort of the best practice we have is the roles and profiles way to do that. And so what I'd create, for, say, like your example, I've got a couple different types of web servers. And they'd all have Apache on them, but I want them configured. They're doing slightly different things. What I'll do is I'll include Apache in all of those, but I won't, I'll treat it differently. And so I'll build it up and I'll be like, well, this is the API. This is the one that's terminating the SSL connections. And I'm going to call this my front end. And then I have a second box that is my, my middleware, whatever the secondary layer. And that's a different profile. And so what I do is you create profiles for a bunch of different aspects, something like base, which might have your NTP and your pseudoers. And then for something like, my API SSL termination profile, and then my, my database profile, or whatever the middleware layer profile, the Tomcat profile. And then you combine all of these profiles together in what we call a role. And so I'll have that one role that includes all the different profiles that matter to that box. So I've got kind of sort of this brick architecture that I can put together. And what I assign to that one box typically ends up being the role, not, I'm not assigning, saying, node X gets Apache with this and all that detail where I'd be repeating it. I'm trying to make blocks that I can put together and then put it all in there. Does that answer your question? Sort of. As far as the internet connectivity between them, and seeing the bigger picture, today Puppet, and that's something that Ryan's here. You touched on a little of the application management he's working on. That's where we're going, is trying to take another layer of abstraction as a company, a way to see that I can see this is the entire application you're running, and that runs across multiple systems, and they have interrelations and connectivity. Today, Puppet works really on a single node basis, and within that node, I can have that connectivity between services and configuration files and all that, and I can see that in the graph, but I don't have that yet beyond that one system, and that's something that App Manager is bringing. Cool. Where was I? Oh, So one nice thing about Puppet, Puppet can not only, so Puppet's all about defined state, and it's something that Ryan really went over in the keynote. But I can not only say this is how the system should be, and then Puppet will check and put it there, but I can also ask Puppet to describe the system as it is right now. So I can do something like, if I typed it correctly, here, I'm not managing root on this system, but I can ask Puppet to say, like, hey, what's it like right now? And so if that's something, this is an easy way to get into writing some Puppet code. If you've got an existing box and you want to know, like, oh, what packages do I have on, or how are the users configured, then I need to copy that. Puppet will tell you in Puppet code what things look like. And that can be used as a basis for actually creating some Puppet code. And I can come in here and modify this and say, well, I don't care to manage that, or that, or that, or this. But I want to come in here, and I want the comment to be something like managed by Puppet. And now, I can actually run Puppet apply, and I can see that code on here, and that it has actually occurred. And it is now managed by Puppet. Well, what happens if somebody else comes in here and changes this? Bob changed it by hand. He was bad. Well, the next time Puppet runs, it's going to notice that that got changed, and it's going to change it back. And that's going to get thrown into the reports. So that, and you're going to see that over here in your reports. You can see, hey, this item was changed, or it's what we call drift away from our desired state. Puppet's going to go in there and fix that. Let's look at a slightly more complicated example here, something where I'm going to try to go here and move up the stack of interesting. So I've created a class here for in my demo module called user. It takes a couple variables, username, password, and then it makes a user. If it's not Windows, it will manage their bash.rc file, and it'll make a group for them. So I can come in here, Linux servers, classes, and let's add that class. And again, I can add data here. So if you guys are familiar with Hira, Hira is often the way that you'll put your data to separate the data from the code. The enterprise classifier also allows you to put the data in this way. This is really useful if you're, once we get to the role-based access control in a bit, if you're trying to give access to other teams to classify some piece or to do development, and they want to make a little one-off change without them necessarily needing to know or use the Puppet code themselves, or to be able to access your Hira, this is a nice way to give them that access. And go Chris, and let's give me a super secure password. And here, so I could use EYAML and encrypt it, but so actually, well, so here in Hira, I could have it encrypted in Hira and EYAML, which I think was touched on in another talk. Today, the Enterprise Console does not provide a way to encrypt things you're entering in here. I could pre-hash the password and throw the hash in instead of throwing a password in. That is one thing that's on our list to add to the classifier, is the ability to contain encrypted information here and manage that information through the console. So now we can see that user's been created. So a little bit more interesting, but let's get up to something that's, so this is a great, so we're telling people getting into Puppet, don't boil the ocean, start with something that you need to do, and then build up incrementally from there. And oftentimes user accounts and packages are a great place for people to start. Then they'll oftentimes go to something more advanced. So I'm going to kick this off and then come back to role-based access control because it takes a bit. So I've got another module here that this is sort of what I consider more of a profile module, although I haven't put it all in a profile, or this is a profile class, but I haven't put it in a profile module because I'm putting all the stuff under my demo module. So basically what we're going to do here is we're going to install Apache, add the EPEL repository, set up MySQL, add WordPress, and then shoehorn in my blog that I haven't updated in 3 years. And then I'm going to do some exported resources. So I'll show you what these do in order to let Nagios know that, hey, this box now is HTTP audit. We should be monitoring that as well. So let's go classify WordPress. And you see with the classification here, I could come in here and do something like cert name, client cert is CentOS 6a, or it gives you the shortcut here. If I can just pin a node to this, if there's just one node I need to do on that. And so that's an easy way to get that in there. And so now, let's get this started. Like I said, this is going to run in the background, so it's going to take a while. While it's doing that, I will explain what exported resources are. So this little @ here, this doesn't actually do anything on that box. What it does is, and how many of you guys are using exported resources and like store configs today? Great. So some people are definitely familiar with this. This is that first step that we did to allow different systems to communicate and to let them know something about another system. This is great for Nagios or setting up something like your load balancer, where those systems need to know information about another system. So what I say here is any box that's getting this weblog class applied to it, not only set up everything it's got, but say, hey, export this information so that Nagios can come later and sweep that up. And then I've got my Nagios server will, actually it's, here, you see these little like rocket things. That's collecting that information. And this will collect all of the Nagios hosts that were exported on any box. We also have the flexibility to do something like tag equals foo. And so say if I wanted to have a Nagios system for each of my different data centers, but I didn't necessarily want to have it collect information about everywhere, I want to just monitor the local boxes, I can put a tag here that says, hey, tag it based on your location, tag it based on whatever I need you to tag on, and then I can collect just the relevant information and have those be created. And so you can see here, right now, I'm currently my base configuration that I'm monitoring on this box. But once we're done, I'll be able to run a Puppet run on the Nagios server as well and collect that those things are now being monitored in addition. And so yeah, like I said, that one's going to take a while. While it's doing that, I'm going to kick off another one that's also going to take even longer. But we can let that go in the background. So IIS Checkout, server, pin. OK, and that one's going to take forever. So I'm going to hit access control, and then I'll go show what I just did. So one of the other things that the enterprise offering includes is role-based access control. So this allows you to hook into any LDAP system, probably your Active Directory, and grab users and groups from there. It's very likely you already have 80 groups that are combining your Windows admins or your developers or some other logical grouping of your organization together. Well, now I can go here with classification. I can come in here and I can group nodes powerfully based on facts. So I can say like my Windows boxes, or I can say my development boxes, group those things based on facts, and then I can come into access control, and I can create something like a Windows admins here, add this from Active Directory, and then give them permissions. Hey, for all the node groups that or this group I created over here, using that facts as define it, these are Windows servers. Well, now give this group access to modify and do whatever they want to do on the system. So now they're able to log in, they're able to assign classification, change data for those particular systems without necessarily being able to affect the other systems that don't belong to them. If you use this combined with R10K and a little bit of Jenkins, you can actually create a workflow that allows people to write Puppet code, publish that to their Git, and modify their own control repo without having access to the branch that you've got the production running on. Jenkins can see, hey, the Git repository was updated. It's going to grab the code, pull it down to update on your master, and then they can come in here and classify that themselves. So you can make it self-service and have that, that ability to control and lock down the permissions in a really advanced sort of mechanism, and use the same Puppet master and the same overall environment to control both your production and your development, your QA, and all that without worrying about the overlap or people breaking something. So let's go look what I just assigned here. Oh, that's not what I want to do. So what I assigned on the Windows side, and this one's going to take forever, so I'm going to talk about it, and we'll probably just look at the one that's already done. I assigned 2 classes, MySQL Web App and TSA SQL Server. So these wrap some of the existing modules we have for IIS and Microsoft SQL Server. As we mentioned earlier, so what Puppet's done a lot is, in the last couple of years, we made a big push on the Windows side to really bring Windows from being a novelty to a first-class citizen in the Puppet world. And among the many things that means, so we've started to write a whole bunch of modules targeted towards the Windows ecosystem. One of which came out, I believe, late last year, was the Microsoft SQL Server. So we can now install and configure and set up a SQL instance by doing something as simple as saying, SQL instance and name and what it should be. Again, classic Puppet, specify just the information that you want and that you care about. So I take some variables here. ACLs, you can manage permissions on the Windows side. And then I stage in this, the installer for SQL, extract it, and then actually install it. And so we can just see here, SQL Server instance, ensure present, what the features I want, and we'll get it all set up for you. And then I can control IIS here as well, which is what I'm doing in the other module. In order to get IIS set up, all the features on there that I need. And then I can attach the database and have my cloud checkout set up. So here, very quickly, and with only a few lines of code that I need to write, I think there's, in between those in there, there's maybe 100 lines of code that are written by me that are just telling other modules what to do. And now 10.20.1, I think it's 19. And it is not HTTPS. I ran it earlier on another Windows box, so it would get it stand up because it takes forever. But now I've got a fully working little checkout that I can get running on here. So you can do really exciting things. And here we are done on this box. So you can ask Factor. You run it live on the system to query what's going on, and I can find out the facts here. So in case I've forgotten what ifconfig is, which I don't think I ever could, but in case I did, I can very quickly get that information. And again, since we abstract everything, we take it on it's the same sort of variable, same command across a bunch of different operating systems, whether that's Windows, Linux, whatnot. We can ask Factor and have it look the same way, and it knows in the back end. So here I've done something very similar to what I was just showing you on the Windows side. I've added IIS, I've added MySQL, I've got all this stood up, forced some data into it, and this whole thing's up and running and off to the races. And then because I had exported resources, if you remember we were talking about Nagios, I can run over here. And I should pick those up. Someday. It's the fun of running like 15 machines on a MacBook Pro. You can see it already got picked up here, actually. So Puppet had ran in the background while I was, that 30-minute window happened to hit between the two of those, but you can see these two services have been added on here by Puppet, and that automatically I was able to bring, without changing any of the configuration on the Nagios server box, because there's new exported resources that said, hey, these need to be monitored. They started being monitored. And so I have those checks in here right now. And you can really dynamically, quickly build your systems this way. Let the systems that need to know about each other, but whether that be your load balancer, your monitoring, or your backup. And you don't have to worry about when somebody builds a new box, did that get into the monitoring, that get into the backup? Because that's part of the whole profile that you've created that says, if you build this, it needs to also be monitored. It needs to also be backed up. It needs to also have whatever else I need to do to that system needs to be configured. And so Puppet allows you to do that programmatically instead of having to come and do it manually, remember, have a checklist. And yeah, this thing's going to go forever. That's why I showed it on there. So that's really like the basic Puppet. There's many, many more hours I can stand up here talking about different topics like Hyra and things like that. Do you guys have questions you want to shoot me over here?
So how do you make a custom fact?
OK, so the question was how do you create custom facts? Custom facts, there's a couple different ways to do custom facts. So I can create in a, CD demo module. So I can do what we call a facts.d folder here. And I can create, and this I can run any arbitrary script that's going to execute on the local system, as long as it's going to return what we call a key value pair. So I can do echo, let's say foo equals bar. No, that's not what I wanted. I need here, vi foo bar. And so that'll then do, you see here, this plugin sync, which is the first thing that'll happen. Before Puppet actually does a factor, it will do the, except I didn't type that right, but. So it'll pull those facts in first, pull all the custom facts in the scripts, and then it'll execute them. I could also just write in the key value pair there and say that I want this to be synced everywhere. So I will just put that in and as a key values, and those will all get combined. I can dump those scripts locally on that system. There's another folder that if you put the fact, a key value pair and its text file on that system, the right location, that'll get picked up by Puppet when it does its run. That's more common for things like having the provisioning box drops a note on there, and then you can decide what you're going to do with that later. The other way to do it is you can write, this is the more historical way, you can write in Ruby, I can do make-dir-p lib factor. And I can come in here and I can make a custom fact in Ruby, which I don't have one loaded on this box, but I can make, just write in Ruby again, like anything that's going to come and return that sort of, is going to return a fact, you can then use that for your HIRA, your classification, any of that. Does that answer your question? Or?
Yeah. Oh, what direction is that?
So there's two sort of magic directories in the profile which will cause plugin sync to do something. One is that facts.d. It will grab anything in there and copy it to the facts.d folder on the client, and then it'll execute those scripts every single time factor is asked for or is run, which will happen before your run actually happens. You report that back to the server. And then the lib, anything under the lib folder gets synced. So anytime you want to extend Puppet, you put it under the lib, and it just gets layered in with the rest of all the Puppet code that runs in that system. So when I want to create something like a new type and provider, that goes under lib as well. There's lib Puppet types and lib Puppet provider, which is the same sort of directory that we use internally in Puppet, and the same code that gets copied from there. And so just lib factor is where the facts that are kept. It's opt Puppet lib. I think it's. Is it? Yeah, site Ruby here factor. So these are all the built-in facts. So you could write a Ruby fact like this that'll go through here and parse like, hey, what is the kernel for this system? And it'll either do it if it's Windows, it'll do it if Windows, and if it's not Windows, it'll do a uname in order to pull that information. Does the same thing, host name, comes in here, tries to figure out what your host name is based on the scripts that can run locally in that system, what it can ask Ruby for, and then any arbitrary commands it can run. And so what you've done with the lib is you're just simply replicating this sort of hierarchy here. So I can extend any of these pieces by simply putting that in the module. It'll be synced over at the beginning of the Puppet run, and then all of that will be available for me to run. Yep?
Can you explain a little bit more about what types of data you put in HIRA and how does it get in there?
Absolutely. So the question was, what types of data are in HIRA and how does it get in there? So for those of you, how many of you guys use HIRA right now? Great. So in HIRA, you have a HIRA.YAML. And this can have backends of YAML, of JSON, or any custom backend you write if you want to tie it to something else. So oftentimes, if there's custom data sources or some asset manager or something else where you've kept some data, HIRA can be written to sort of look into that. So what it does, the way to think about HIRA is sort of, if you remember the old transparency overhead projectors, this is a series of layers, which you can layer up in order to provide all of the variables that a system might need. And so I can say, well, here's my common here. This is what I want to be on every single system. But if it's virtual or if it's in this specific data center, maybe in this data center I want to use different NTP servers. So I'll use the US NTP servers for the Americas or for Portland, and I'll use the Australian ones for my Sydney data center. I can provide this kind of information. This will then override, if it's specified lower on this, something higher will override that. I can also combine all this together. So I can say, do what's called a HIRA hash. So this is common for things like user accounts, where in common I might have, I need this user on every single system that I have with this password and these permissions. But then in my development environment, I need these other users to also be on there, which is different than my production environment, because I don't want the developers to know the local credentials. And so HIRA hash can grab all of that information. It says, tell me all the users in HIRA for this system, and then it'll pull all that together and turn that into local user counts. The value of this is separating, so I can actually, here I've done exactly what I was talking about with NTP. You can see I've got NTP servers here for Portland and for Sydney, I'm using different servers. And so this is something that happened, I think, starting in Hire 3.3, which is called these black magic lookups. So right now, if you see, if I go look at the NTP module, modules, NTP manifest here. So there's this variable here, servers. This looks up from the params file, which you can see is set based on kind of figuring out what the local system is. It'll decide what that should actually be. But if I give it the exact path name, so because that's to what the Puppet sees as a variable, if I put that in Hira, Hira will do a lookup. Every time there's a variable you can specify, the Puppet does a Hira lookup and say like, hey, do I know that already? So here, I've specified the exact variable name. Data centers, which here is class and then the name of the variable. If it's a subclass, it'd be class, then subclass name, and then name of the variable. Because I specified it like that, it's going to find the lookup, it's going to override. This has the people that like this and people that don't. The people like it, it takes a lot less code to write because I don't ever have to write in, do this lookup. And it will do that lookup based on my Hira hierarchy. And I can very quickly, without a bunch of case statements and if statements put around there, I can very quickly get unique data and pull that in. On the other side, some people don't like it because it makes troubleshooting a little more difficult because you're like, where the heck did this variable come from? It just appeared out of midair. So that's why some other people, myself included, like, where's my Razor demo? You can see what I've done here is I've made explicit Hira calls to pull this data and then back-end it with looking at my params if it doesn't happen to be in Hira. This line that I have here, the Hira is, actually with Hira hash, if I want to combine it all, I do need to put this in there. But normally it's just a Hira lookup like this. It would be a redundant line, but it does make it easier in troubleshooting to go back and say, hey, oh, that's where this information is coming in. I should look at Hira instead of, you have to remember that. No, if you go into Hira and you write this Razor demo ::DNS config dir in there, it'll pull out a Hira first. Does that provide more clarity? Great. More questions? Anybody? There's got to be something else that questions about or wondering or that is not working for you in Puppet?
Something keeping you up at night, haunting you throughout the day. Yeah, back there.
Creating another master is one of the things I want to make sure I have. One physical separate machine. Even though I have the database that's the same for all machines, adding another server so that I'm officially not having any of my production servers talk to machines that are dev servers.
Mm-hmm. So, I mean, yeah, you can have.
Do you want to repeat the question? Sorry.
Oh, sorry. Yeah. So his question was how to have multiple masters, and as let me correct me if I'm wrong, but this is kind of the workflow to have multiple masters in order to divide the actual load that's coming from development and those to compile masters that are not also serving the production environment. Is that correct? All right. So. Yep, and you can absolutely do that. The way that, so one of the nice things that PE3.7 provided was that instead of before where you had to run the installer in order to build a new master, we've now created a class, and we've have this built-in group here for each of the different roles that exist on the master, and so I can. To accomplish the first part of building another master now is as easy as I've got an agent running on that box already. I classify it as a master. And now I just need to be pointing the boxes at the right master. And so that's modifying their puppet.conf to point at the particular master that they should be looking at. And you can set this based on a variable that says, well, you're in an environment. So that's one of the things we added in 3.8 was these things called environment groups. So production, by default, is an asterisk and grabs everything. But I can find other ways, based on what data center you're in, based on what subnet you're running, whatever that, I can define a group that says this is the environment you're in. And then for that environment, I can specify in your puppet.conf, the server line, like file line there, you should be talking to this particular master. And if I want to do it in a highly available situation, I probably will be pointing them then actually at my F5 or my load balancer or my HA proxy, whatever, so I can hit that. And I'll be updating that load balancer every time I've added another compile master there. I can tell the load balancer, hey, this is a compile master that should be used for development. Include that in there. And you'll have all the clients will be configured. If you're in this environment, you should be looking at this IP or this host name that will get you to the right compile masters. Cool.
I'm trying to solve a scenario where I have, for example, two services. For example, if one service has some problem, or I made some changes to the first services, then I want some automated procedure to update this, restart the second services. Like if there's some dependency between these two services on different servers, is there anything that I can do?
That's what App Manager is coming for. So again, as you're aware, like on one box, I can do a notify or subscribe to sort of accomplish that. But across multiple boxes, this is something that the industry in general has been working towards solving, is how, because my applications are no longer within one machine, they now span multiple machines. And oftentimes I've got things like a load balancer up front and a bunch of nodes in a database. And I may need to actually update the code on all of those nodes, and I need to pull them out a few at a time from the load balancer, change them, make sure that that update worked properly, and shove them back in, and then move on to the next. And that's what App Manager is looking to solve. So that's something at PuppetConf, Ryan will be giving a lot more information on that and where we are on it. But yeah, that's the direction we're moving in, because right now people do a bunch of different screwy things to sort of accomplish that. They'll often use something like mcollective, which I didn't show mcollective, so I'll do that here real quick. But they'll often use mcollective to say, let's disable Puppet on these nodes. Let me go change the code, and let me then, or tell, like I do a Puppet, and do actually the commands to pull it out of the proxy server, whatever I need to do, and then do it in mcollective to make that happen. But it's kludgy. Oh, no, it's not the right box. It's kludgy today, and that's something that's going to get cleaned up a lot and become a lot easier with native Puppet code to accomplish that. Those sort of things to understand, to update your system, and to handle that with App Manager. How many of you guys have used mcollective? Great. So mcollective, the Marionette Collective, is our orchestration layer that allows you, so it runs active MQ bus. All the systems have long-lived SSL connections connecting to it, and they're monitoring that bus to say, hey, do I have anything that's going on? And you'll put a message out there that says, OK, for all of you boxes here, let me know that you're alive. And it'll go through, and it can be like, oh, these are all the boxes that are up, and how long it takes to go through the system. I can also do a query, I want to say, what's the status of bash? Because something like shell shock happens. What's the status of bash across all my systems? I can find that out very quickly. If I want, limit that down based on factor to only particular nodes. Maybe I only care about one data center, or I care about certain things. I can then do Puppet runs this way. So I can do Puppet. I can do run once and cause Puppet to run either on a particular node or a set of nodes. Or I can do like a run all, because maybe I don't want all 5,000 boxes hitting Puppet right away. So let's do them 2 at a time. And Puppet will go through here and have these happen. They kick off the Puppet runs 2 at a time and get them going, wait till they finish, and then start the next to go through all of your systems like that. I can also mcollective does allow you, if you enable mcollective shell, you can do any arbitrary commands out on there. That's sort of I've seen people, it gives them some of the functionality that they might use something like Ansible in conjunction with Puppet to do like here, 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 and here, and run arbitrary commands. I mean, the trick with that is making sure that you're maintaining the item potency and the infrastructure as code. And if you're actually updating systems in mcollective, this isn't logged in your Git or anything like that. So it's a tool that definitely is very powerful, but you've got to find the right place to use it in order to not break your systems or not wonder what happened or how you ended up with a special snowflake. Cool. Did that answer your question? Or, I mean, that was my answer was I don't have an answer, but yeah.
Excellent. Thank you so much, Chris.
Absolutely.